Today we are going to see about the problems in bus impedance matrix by using the bus building algorithm. So take down this example. For the system shown in the figure, form the bus impedance matrix using the bus building algorithm. Okay, so this is the system shown in the figure, whereas you are having three buses. Okay, three buses, and impedance between 1 and 2 is 0.2 J. Impedance between 3 and reference is 0.2 J. Next, impedance between 1 and 3 is 0.4 J. So here you are taking this bus as a reference bus. Okay, so what they said is they said to formulate the impedance matrix by using the bus build algorithm. Okay, so now what is the solution number one? Add an element between the reference and the node one. Okay, so which is the reference we have taken? This is the reference. So between the reference and node one, we have to add an element, that is first element, that is j into 0.2 j. So correspondingly, we need to frame the Zbus matrix. So what is Zbus matrix? Now it is only one element. So it is 1 cross 1. Okay, 1 cross 1. So the matrix frame like this. Zbus is equal to j into 0.1. Framing this matrix, what is the step number 2? Step number 2 is add an element between the existing node 1 and the node number 3. So we need to add another element. Okay, so another element in the sense from the product. So this we added, that is from 2 to 1 we added, that is 0.2 J. Now we need to add the element between this element. Okay, 1 and 3 we need to add. So that's what we added. Add an element between the existing node and the new node. Now this is the existing node, new node is 3. Okay, so 1 is the existing node, new node is 3. So we are adding 0.4G. Again, we are framing the Zbus matrix. How to frame the Zbus matrices? Sense. So whatever the, say for example, in this particular, so in the particular place, so you will be having some values. So that you need to copy here and also copy here. Like okay, so it is like a L type. You need to make L type always. Okay, so whatever the values here, okay, so whatever the values here, so the same thing you need to copy here. Okay, so rows. So whatever the rows, you need to copy the same thing. So here also column, you need to copy the same. Okay, so that you need to remember. Okay, so next is what is the next one? Yeah, Zbus equal to this. We need to frame. What is the next one? This particular part. So now we we added. Okay, so whatever the element here, we are adding here and we are adding here. Okay, so now what is this element is? So okay, so this j into 0.2, that is 0.2 j plus whatever the new reference added. So in the new reference, so the value is j into 0.4. Okay, so that you need to add. That is j into, that is here, j into 0.2, j into 0.2 plus j into 0.4. Okay, 0.4. So that is this value, that is 0.6. Okay, so now we frame this particular step number 2. So what is the step number 3 is? Step number 3, add an element between the existing node and the reference. Add an element between the existing node and the reference node. That this reference we need to add. Existing node what now? 3. Reference node what? 2. Okay, so existing and reference node, what is the element here? J into 0.2. Okay, so here we are adding j into 0.2. Where here, this part you are adding j into 0.2 is the element between the 3 and reference. So here, so as I said, okay, this particular thing is the same, that is L. Okay, this and this is the same, this and this also same. So here, whatever the value is there, say for example, 0.6 is there, here also 0.6, here also 0. So this particular value, how so the same value that is nothing but j into 0.6, j into 0.6 plus j into 0.2. J into 0.6 plus j into 0.2. So this this particular element plus this element, whatever the element between this existing node and the reference node, that is 0.2. So that is nothing but j into 0.8. Okay. Now what we need to do is we need to reduce this reduce this matrix, okay, by using the Cron's reduction method. So what is the formula for Cron's reduction method? The formula for Cron's reduction method already we have seen. Okay, that is Z of jk of m bus is equal to Z of jk minus Z of j into n plus 1 into Z of n plus 1 into k divided by Z of n plus 1 into n plus 1. Okay, so where j is j comma k is equal to 1 up to n. Okay, so this is the thing to add an element between the existing. So we frame the Zbus matrix. So now by Cron's reduction method, what is the general formula that we have seen? So the same thing you need to substitute here. So by substituting, Z11 is equal to Z11 minus Z13 into Z31 divided by Z33. Okay, Z of j comma k is equal to Z of jk minus Z of j into n, that is here the general formula by using j into n plus 1 into Z of n plus 1 into k divided by Z of n plus 1 into n plus 1. Okay, so what is n? N is nothing but so here the number of rows. Here you are taken as a reference node, to second node as a reference node. So what is the total number of nodes is 2. Okay, so it is 2 plus 1 is 3. Okay, so here Z of 1 3 into Z of 3 1 divided by Z of 3. Okay, so like that similarly. Next, Z12 is equal to Z21 is equal to Z12 minus Z of 13 into Z of 32 divided by Z of 33. So that those values you need to substitute because Z bus is there now. So what is this? Here it is Z11, Z12, Z13 like that. Okay. So Z13, okay, so here how they did is they framed based on the reference node Z1, 3 and 0, 1, 3 and 0. Okay, like that they frame. So what is Z13 is nothing but 0.2. Okay, Z13 or Z31 is 0.2. So whatever the value here, Z13. Okay, so why Z13? You may have doubt. It should be 1, 2, 3 like that. You may have doubt. So here we have taken as this reference node we have taken as second node. That is second node we have taken as reference node. So here it is reference node is nothing but 0. So 1, 3, 1, 3. So 1, 3, 0. Okay. So Z13 is nothing but this value, this particular value. Okay. This particular value that we are taking. So this particular value, that is Z13 is nothing but 0.2j. So that you are substituting, and Z33. What is Z33? Z33 is this. So Z31 is this. 31 or Z13 is this. Okay. So Z13 is this because all same. So you'll get the same values. Okay. So or otherwise you go, better you can go for the same thing. 1, 2, 3 like that also you can take. Okay. But where is Z13? Z13. Z13 is 0.2 because this say all are same values. So wherever you take it will come the same. Okay. Now next Z13 into Z31. Z13 where yeah, Z13 is 0.2. Z31 where Yeah, 3, 1 is 3, 1 also. Z1, 3 is also 0.2. Okay, divided by Z3, 3. Z3, 3 is 0.8. Z3, 3 is 0.8. So that you are substituting. So they don't take this as reference, because if you take this as reference, again, you will get confused. Better you can go with your own numberings, reference number 1, 2, 3 itself. Here also 1, 2, 3. So that you can easily, okay, next Z1, 2 is equal to, so this you need to substitute Z12. Similarly, you will get the answer like 0.05 G. Similarly, Z22. Z22 is nothing but Z22 minus Z23 into Z32 divided by Z33. Just you are substituting 0.6J, 0.6J, 0.6J divided by 0.8. So you'll get the answer as 0.15J. Okay, so you'll get Zbus values as like this, just by substituting. Okay, Z11, Z12, Z21, Z22. So these two values are same. This value you need to calculate and you need to keep. Okay, so like that it will come. So one more shortcut method I can teach you. One more shortcut method. Instead of using this Cron's reduction formula, you can use one more shortcut method. So how that shortcut method is? So how to reduce this buses? Okay. So here, say for example, first you need to take this 2 cross 2 matrix alone. First you need to take this 2 cross 2 matrix alone. Say for example, 0.2. 0.2. Next is J into 0.2. Here also J into okay, 0.2 or 0.2, 0.2. So here also J into 0.6. Okay, so this you take as it is. This is 2. Okay, minus. Okay, so 1 divided by this value. This value. So whatever the value here, this you need to take. J into 0.8 into, okay, so here into this particular matrix, that is this particular matrix. Okay, say I'm using different colors so that you can understand. Now this particular matrix you need to take out. Say for example, J into 0.2. Here also J into 0.6. J into 0.6. Okay, so this we take. Next, what you need to do is this particular matrix. Again, I'm using different colors. Okay, so this particular matrix you need to take. Where, yeah, this particular matrix you need to take and you need to multiply. Okay, say for example, 0.2, 0.2 J into here also J into 0.6. Okay, this particular matrix you need to take out and you need to multiply. Okay, this is the shortcut method. So whatever the matrix is there, here you need to take outside. Okay, this 2 cross 2 matrix you need to take outside minus 1 divided by this particular value, that is J into 0.8 into this two elements. Okay, this two elements. Okay, row elements, sorry, column elements next into this row. Okay, this row J into 0.2, J into 0.2. So if you multiply this, the same you using your scientific calculator, or I think this is very simple. You can do it directly also, or otherwise if you want, you can go for the scientific calculator. Whatever the calculation you do, the answer will be same. Answer will be same. That whatever the, say for example, here it is there now, this same answer will come. Okay, this method is common for all. Okay, so whatever the problem, either it might be 4 cross 4 matrix, it might be 5 cross 5 matrix, whatever the answers you take, this will be the answer for this particular thing. Okay, this is the shortcut. Okay, you follow this shortcut. Okay, or otherwise, Sir, the shortcut is not understanding better for me. You go with the formula. That is your own wish. Okay. But as per my knowledge and as per my experience, so I'm telling you, for saving the time, you can go for this shortcut method, because the thing is that if you need to write the cross reduction formula, you need to substitute it, and correctly you need to substitute this Z22, Z23. Correct. If anything goes wrong, wrong here, the entire problem will be wrong. So better you can go for this shortcut method for acquiring the answer easily, and time also will be saved. Okay, so you can also take one homework. You can also solve by two methods. You see the time, how much time it is taking for you to solve by using Cron's reduction method and this shortcut method. But I hope so. The shortcut method you will solve soon also, very soon also. But this is simple calculation only. You need to do very fast. Okay.